Hello everyone. Today we will see how to install PowerSimData from Breakthrough Energy and how to use it in conjunction with Reise package, the renewable energy integration simulation engine package and how to run simulations with it. So we have previously installed Reise package and we have set it up on Google Colab. So I have copied those scripts and run it, and which already have now installed Reise. It has cloned Reise, it has downloaded Julia, and it has added the Reise package to Julia. So now the next step is that we need to be able to call Reise and the GLPK, the solver package, from Python. So for that we need to install the necessary Python file, so that from Python we can call or we can import the Reise package through Julia. So let us I have some files on my Google Drive which already I have mounted, and we can copy it. The name of the file so we need to see. Okay. So before that, we can actually have a look at the actual requirement in the folder, the Reise folder. The thing is, the H5PY, I was unable to find a package with that 2.100 compatible version. So what I did, I installed it directly. Install H5PY, which is already there, I believe. Okay, so now the next thing is, instead of using this, either we can remove manually from that and or ash it out, and then or you can install it one by one. So I have this file which I just copied from the Google Drive. It contains the list with just the first item, the H5PY module hashed out. So let me now install pip install -r Reise. If you want to, before that, just have a look at it. It is simply this is it. It has just hashed out that particular line so that it doesn't install it again or throw an error. Okay, that's all set. So now what we are going to do is we installed the necessary packages so that from Python we can call the Reise. The next step is to clone PowerSimData. So let us git clone PowerSimData. This is a package which is used to download the input files, reformat it, and do necessary checks for consistency, and then it will upload, or it will call the reise and start the simulations. So now we have the requirements for PowerSimData as well. So let us have a look at that. Cat data. So here everything works perfectly fine, except the last one, FS Azure Blob. The thing is, it is the module so that we can download the files from Azure Cloud and use it for the simulation purpose. The setup says that it needs Python 3.8 or above, but the version of Python that we use in Google Colab is 3.7. I tested if 3.8 works, and it works, but it won't allow you to install unless you modify in the configuration file that 3.8 works. So I basically updated the configuration file and installed it. So first we are going to install, I have a requirement file with just removing this one, the last one, which we will install separately. So we'll install the first through the second last. So I'll copy the file from Google Drive. Copy as, and this is all the requirement except the Azure Blob. So let us now see what it is there. So you can see that I have removed the last one. So we install -r. Okay, so now we are going to get the Azure Blob, which we can clone it again. It is provided by Breakthrough Energy. I'm going to copy the file, the configuration file, which I have modified. And it is called the setup. I'm going to put it here. Yeah. So if you want to have a look at it, just cat now this will be the modified one. Blob. So setup config. So if you just walk through it, somewhere this is the line. So it was 3.8, so I modified to 3.7. So now we need to install it. So for that, we are going to cd into fs Azure Blob. So we're inside now, and we need to say pip, say install. Okay, so it is installing FS Azure Blob. So we have at this point installed all the necessary packages, Python packages. We can actually restart the runtime. The next step is we need to create create some folders, scenario data folders, where the program can save input and output files. And also we need to do some configuration of PowerSimData, a file which needs to be put in the PowerSimData root folder, so that PowerSimData can find Reese. So I'm going to first do the configuration file. It is called config.copy. So this needs to go to PowerSimData, and actually it need to be called config.ini. I copied that. Let's have a look at it. So cat PowerSimData, what we did, config. Yes. So we have here two environmental variables, engine directory and Julia project engine directory variable and Julia project, which is basically pointing to where Reese is installed. And we can also create an environmental variable. We say echo Julia one. And take this. Okay, equal to we're going to put it inside. We're going to append it to bash rc. Bash. And now we are going to source it. Could say source. Okay, so the next step is to create the scenario data folders, and also inside the scenario data folders there will be two lists, two CSV files which contains information like the scenario data ID when we ran the scenarios and different details of the scenario that we ran. Everything will be accumulated over time as we keep on running the scenarios. So for that, first of all, we go to PowerSimData. Let's see if we can import. Okay. So now let us create that configuration. All the basically we are going to create the configuration files, all the scenario the folders necessary to create, necessary to run the simulations. So we can see as root So we have at the moment execute list.csv, scenario list.csv, which will save the IDs of scenarios and other information when we run simulations. Let us now create some folders which the program otherwise will ask during the run and in the execution will stop. So I'm going to create beforehand. So one is, so let us say make directory data. I say the one is raw folder, and inside that we need USA channel. This is a place it will download the profiles. USA channel is the grid model that we are going to use, and so it will download and save all the profiles there. Okay, and another thing, once we do the simulations, it is also going to ask us it's going to ask us for some place to save the data after the simulations are run. So we call data folder. So now we are going to make, okay, and we need a couple of more folders. Input, output, input, data, USA time raw data. Okay, so now we have everything we need to proceed and do some calculations and run some simulations. I have a basic file here, an example which I got from the tutorial sessions, like the tutorials on the Breakthrough Energy website. So here we create a scenario which is actually imported from the PowerSimData, and we use the Western interconnect. We create test and the names, the plan names, and the name of the scenario. The data I modified to pick up a very small range, so the scenario runs quite fast for the demonstration purpose. And we initialize the base profiles, all the 4 of them. And finally, we have created the scenario, and we'll prepare the input and the launch simulation. Here you have the solver. GLPK is a solver that we are using, which we already have added into Reise package. And there is also other ones, the Gurobi, which is one of the solvers which is commercial but can be downloaded for academic purpose. It is the default. If you don't give it, it may throw error saying that Gurobi is not installed if you don't have it. And also we can pass a flag called extract extract output, and at the moment it is yes. So after the scenario is run successfully, it is going to extract the data for us. So we are going to run the simulations. So it's downloading the necessary profiles. At the moment, it is the PowerSimData prepared simulations and it is submitted to Reise. And let us see the status. So we can look at a scenario dot prints status. It says running. We can have a detailed output. We say scenario dot check progress. It is the Julia engine is running it. It will be importing the reise and glpk. So now it has started actually running. It is loading the case.mat and all the input files necessary to run the simulation. So now it says the redirecting output. So it will go, the output will be saved in the beginning in a temporary folder inside the scenario data temp folder, scenario_1, and then later it will be extracted. Now we can see that the output has changed to finished. So it will be in the status of it will be now extracting the data from the results which is already saved after running the scenario. So it is in the process of extracting the data. Once it is extracted, it will change to the analyzed state. So we can now see this, the status has been updated to extracted. So the scenario is successfully run and it is extracted, and now we can proceed to analyzing the data and looking at things like local mean prices, local marginal price, LMPs, and congestions and all other results. We can do those calculations. We can do those analysis using post-reise package. So that's it for this tutorial, and thank you very much for watching.